Okay, so we're looking at second year stats and mechanics textbook, and we're on chapter 6, which is projectiles, looking at exercise 60, which is projectile formulae. So we're up to question 5, and this, I think, is the first exam question. They've all been problem solving because this topic is basically all problem solving. So we've got some mark allocations. So we can see the first bit is worth 4 marks. Okay, so what do we got? We have got a particle projected angle of elevation alpha with an initial speed of u, moves freely under gravity. So basically it's going to sort of carry on going up. Gravity is going to slow it down, and then it's going to start coming back down again. And I think we did see this in an earlier question. So we're basically saying at any point on that journey, the vertical distance it's travelled, or its height above from the origin, is y, and the horizontal distance it's travelled is x. Okay. And then we want to come up with something linking x and y. So this actually is very, very similar to question 2. Okay, so if you've done question 2, this is a really, really similar idea. And then all of this information is not going to be relevant for part A. So in fact, let's cover that up so it doesn't distract us. Okay, maybe let's not do that. Right, okay. Okay, so how are we going to do this? Well, so basically I want to, so x and y are its 2 displacements. X is its horizontal displacement and y is its vertical displacement. So I definitely need to think horizontally and vertically. Okay, so horizontally, let's do that first just because that's a little bit easier. Because horizontally, so its initial velocity horizontally, so it's velocity, initial velocity in that direction, well, so that's adjacent to alpha, so that's going to be capital U cos alpha. Its initial velocity vertically, might as well do that whilst we're thinking about this, so its initial velocity in that direction, well, that is opposite angle alpha, so that's going to be capital U sine alpha. Okay, right, so then, and horizontally, they've told us that its horizontal displacement we're calling x. And always with this type of question, it's t is going to be what you're interested in, because t is what links the horizontal and the vertical motion. So if I take this point here I'm highlighting is just a random point. I could be looking here, I could be looking here. But basically at this point, the time is going to be the same. Yeah, the vertical velocity will be different to the horizontal velocity, the displacements won't be the same, but if it's that point after 2 seconds, the horizontal time is 2 seconds, the vertical time is 2 seconds. There's no difference between the two. Right, so horizontally, there is no acceleration. So I could use acceleration of 0 and use suvat. So some of the early examples I did, and all that happens is you're going to use s is ut plus a half at squared, and the half at squared ends up equaling 0. It's actually much quicker just to say, well, if it's constant velocity, displacement is velocity times time. So displacement, which we're calling x, is velocity, which is u cos alpha, and that's not changing, that's constant, times time. Okay, and that's the first equation that I need. Okay, so if I do the same thing vertically, oh, no, sorry, I really should have said I'm taking to the right as positive there. So vertically, I'm going to take up as positive because that initial velocity is up. So vertically, the acceleration is obviously due to gravity, and if I'm taking up as positive, that's going to be minus g. The displacement vertically, they've told me to call y, and t is just t. So for vertically, if I use s is ut plus a half at squared, so s, perhaps you can see, so s is y, u in the vertical direction is capital U sine alpha, and t is t, and then plus a half a, Well, A is minus G, so I'm just going to put the minus there straight away. So that's minus a half G T squared. Okay, my alpha looks a little bit like a 2, so I'm just going to write that again. Slightly better. Okay, and that's the second equation I need. So these really are quite tricky to start with, but if you can make your way through a few of these, you will start to see that they are pretty similar. And these questions where you're trying to find a connection between horizontal and vertical displacement, it always involves thinking about T. Okay, so what I'm actually trying to get to, I'm trying to get to an equation with y as the subject, which I have got, but obviously that's not the same as what they've got there. So what's different? Well, theirs is not in terms of t, theirs is in terms of x. So I don't want to start rearranging this because I want y as the subject. And I know like they've got a tan and we haven't, but we'll get to that, that'll be fine. So if I want to eliminate t, the most sensible thing is going to be to make t the subject of this one. So just divide through by the u cos alpha and then substitute it into this one. So y equals capital U sine alpha, and then that t I'm going to substitute for x over u cos alpha, and I'm going to run out of room, which is annoying. I'll see if I can just fit this in. Okay, so then minus a half g, and then again, where it's t, I'm going to substitute in, just going to squeeze that in, that all squared. Okay, right, so now I'm just going to keep my fingers crossed that we can get what they've got there. So what's going to happen? Well, that u and that u can cancel. Sine alpha over cos alpha, I know is tan alpha. So I think we're all right with the first part. So we've got the x tan alpha, so that's good. It's a little bit like a 2. Okay, so then I've got the minus a half g. In fact, no, that's fine, I'll leave that. So let's square out those brackets. So that'll be x squared in the numerator and u squared, and cos alpha all squared. You know from sort of all your trig identities that convention says we write that as cos squared alpha. Okay, and then I think we're there. So let's just neaten that up. So I've got the x tan alpha. Okay, I'll do my x tan alpha. And then, so the half so if I just want to tidy that up and write that just as a fraction, I've got gx squared in the numerator. The half can just come down as a 2 there. And I've got the u squared. And I've got the cos squared alpha as required. Job done. Okay. So that's 4 marks. That's almost half the question. Right, and then the other one important thing about this type of question is you can probably answer part B even if you've got a little bit lost with part A. So let's have a think. Hopefully that's true. Right, a boy throws a stone from a point P, the end of the pier. The point P is 15 meters above sea level. In fact, this might even, let's start drawing this out because this might even just be a completely separate question. In fact, let's see. Okay, so he's at the end of a pier. He is projecting it with a speed of 8 at an angle of 40 degrees. So it's going to move freely under gravity, so it's going to go up for a bit and then come back down. And we want to find the horizontal distance of the stone from P. So P is where he chucked it. So P is our starting point. But that was 15 meters above sea level. So I think we are going to be able to use our previous answer. You could restart the whole question, particularly if you got a bit mixed up on A, but that would just take a little bit longer, right? So this is sea level. So I want to know it's another colour change, right? So they're asking me, sorry, my sea level's not very flat, but pretend it is. Let's move that down a little bit. Okay, so stop being lazy and draw that out a little bit neater. Right, so there's sea level. They told me in the question that he was throwing it from 15 meters above sea level. And I want to know, and that's the stone, so that's where it hits the water. And they're asking me about when it's 2 meters above sea level. So that's not 2 meters above where he threw it. That's 2 meters above sea level. And they want to know its horizontal distance at that point. So they basically want the value of X. So I can use my previous answer, just got to be really careful about what I use for Y. So because when I answered part A, Y was relative to the start position. So if we figure this out, I think this is quite a nice 5 marks to earn. So let's move it up so you can see it a bit better. So when is it 2 meters above sea level? Well, that's going to be, obviously this is not in the slightest bit drawn to scale, but that is going to be when it's 13 meters below where it started. Okay, that's purely from, it started 15 meters above sea level. So when it's 2 meters above sea level, it's 13 meters lower than when it started. So basically, I want to find X when Y is minus 13. So that's not going to be as straightforward as I think I might have hoped it would be. So if I go back, I'm just using this equation. So as I said, you don't have to start the whole question. So Y is X tan alpha, or when I know alpha, don't like alpha, is, what did they say alpha was? They said alpha was 40 degrees, that's the angle of projection. So Y is X tan 40 minus G X squared, and obviously I know G is 9.8, so I can sub that in. In fact, let's just sub that in now. Let's sub all our values in. So minus G X squared all over, so I'm looking at this equation here, 2U squared, and they told me what U was. They told me that U was 8. So 2 times 8 squared times cos alpha all squared. So cos 40 all squared. Right, so no, I take it back, it's actually not that bad. I know it looks quite nasty, but I was thinking we might have to solve a trig equation, but it's actually just a quadratic in X. So let's stick some values into our calculator. So I've got minus 13, tan 40 is, so I'm going to go to a few significant figures here so I don't lose any accuracy. So 0.8391. I think that should be okay. So that's just the value of tan 40. And then basically all of this is just going to be my coefficient of X squared. So that can just go straight into my calculator. So 9.8 over 2 times 64 times, just be careful how you type this in. So cos 40, all squared. So make sure you're not squaring the 40 degrees, you're squaring the cos 40. So that, if I've typed that in correctly, is giving me 0.1305 x squared. And I don't really care that that looks quite nasty because I'm just going to put it into my calculator. So I'm going to add everything over to the left-hand side. And scroll up so you can see it. Okay, so I'm just going to quadratic solve mode in my calculator, keeping my fingers crossed we get the right answer. So A is 0.1305, B is minus 0.891, C is minus 13. So that is giving me X 13.96, or X is minus 7.13. And as far as I can judge, I'm quite happy with those because the negative answer obviously is not relevant, but this is basically a quadratic, so it does make sense that there would be a negative solution So not relevant in the context of this question. So I would be guessing X is 14.0 meters. So my only worry there is whether I rounded a bit too much and lost some accuracy. Let's see. 13.7. Okay, so yeah, I'm going to say, if I just go back to my working, that my issue was, and possibly my answer would have been okay, but yeah, I think my issue is I'm not going to do the whole thing again, but let's do that. My issue, there in the end, is that I probably rounded those too much. Okay, so that's just need to be careful there.